Volcanoes are among the most awe-inspiring and powerful natural phenomena on Earth. These geological wonders have shaped the planet's surface, provided fertile lands, and created catastrophic events that have altered the course of human history. Despite their destructive potential, volcanoes are essential to Earth's geological processes and even play a role in sustaining life. Volcanoes exist due to the intense geological processes beneath the Earth's crust. The planet's outer shell, or lithosphere, is divided into tectonic plates that float on the semi-fluid asthenosphere below. These plates are constantly moving, and their interactions create conditions for volcanic activity. Divergent boundaries. At mid-ocean ridges and rift valleys, tectonic plates pull apart, allowing magma to rise to the surface and form volcanoes. Iceland, sitting on the mid-Atlantic ridge, is a prime example. Convergent boundaries. When one plate subducts beneath another, it melts in the intense heat and pressure of the mantle, creating magma that rises to form volcanoes. The Pacific Ring of Fire is home to most of these volcanoes, including Mount Fuji and Mount St. Helens. Hotspots. Some volcanoes form away from plate boundaries due to mantle plumes, or hotspots, where magma pushes through the crust. The Hawaiian Islands are a product of this phenomenon. Volcanoes serve as pressure release valves for the Earth's internal heat. Without these outlets, the planet's interior pressure and temperature could disrupt its delicate equilibrium, affecting everything from plate movement to atmospheric stability. A volcano acts as a natural vent for magma, gases, and ash trapped beneath the Earth's surface. When pressure builds due to the accumulation of magma in underground chambers, the Earth's crust eventually gives way, resulting in an eruption. Effusive eruptions. In these types of eruptions, magma flows steadily to the surface, creating rivers of lava that spread across the land. These are often less violent and are characteristic of shield volcanoes like those in Hawaii. Explosive eruptions. Thick, viscous magma traps gases, building immense pressure. When this pressure is released, it causes violent explosions that can send ash, gases, and rocks high into the atmosphere. Stratovolcanoes, such as Mount Vesuvius, are known for these dramatic eruptions. Volcanoes can remain dormant for hundreds or even thousands of years before erupting again, making it challenging for scientists to predict their activity. Understanding their behavior is crucial for mitigating their risks. Earth is home to approximately 1,500 active volcanoes on land, but the majority of volcanic activity occurs underwater along mid-ocean ridges. These submarine volcanoes form chains stretching thousands of miles, releasing vast amounts of magma and contributing to seafloor spreading. Some of the most famous volcanoes include Mount Etna, Italy, one of the most active volcanoes in the world. It has been erupting for thousands of years. Kilauea, Hawaii, known for its relatively gentle eruptions, it has created new landmass over time. Mount Nyiragongo, Congo. This volcano is renowned for its lava lake, one of the few persistent lava lakes in the world. While some volcanoes are closely monitored, others in remote areas pose hidden risks. Volcanoes aren't unique to Earth. They are found on other planets and moons across the solar system, revealing fascinating insights about these celestial bodies. Mars. Olympus Mons, the largest volcano in the solar system, towers at an incredible 13.6 miles high and spans 370 miles across. This shield volcano, now extinct, is evidence of Mars's volcanic past. Io, Jupiter's moon. Io is the most volcanically active body in the solar system, with eruptions spewing sulfur compounds and painting its surface in vibrant colors. Venus. Venus hosts thousands of volcanoes, many of which may still be active. Its thick, hot atmosphere, composed mainly of carbon dioxide, traps heat, creating conditions similar to a greenhouse. Triton, Neptune's moon. Triton exhibits cryovolcanism, where instead of molten rock, it erupts water, ammonia, and methane, creating geysers of icy material. Volcanoes in space demonstrate that volcanic activity is a universal process, shaped by the conditions of each celestial body. Volcanoes are as mysterious as they are mesmerizing. Here are some intriguing, lesser-known facts. Volcanic lightning. During explosive eruptions, ash particles collide and generate static electricity, producing stunning volcanic lightning. Largest lava lake. Mount Nyiragongo in the Democratic Republic of Congo contains one of the largest and most active lava lakes on Earth. Life in harsh conditions. Microorganisms thrive in the acidic and high-temperature environments of volcanic vents, hinting at how life could exist in extreme conditions elsewhere in the universe. New land. Volcanic eruptions can create new islands. For example, Surtsey in Iceland emerged from the ocean after an undersea eruption in 1963. Throughout history, volcanic eruptions have caused devastating effects. Mount Tambora, 1815. This eruption in Indonesia caused the year without a summer, leading to global crop failures and widespread famine. Krakatoa, 1883. Its explosion was one of the loudest sounds ever recorded, triggering massive tsunamis and killing over 36,000 people. Hunga Tonga Hunga Ha'apai, 2022. This undersea volcano's eruption was so powerful it disrupted global weather patterns and created a sonic boom heard worldwide. These events highlight the global consequences of volcanic activity. Volcanoes impact the modern world in significant ways, both positive and negative. Volcanic ash can disrupt air travel, as seen during Iceland's Eyjafjallajökull eruption in 2010. However, volcanic soil is incredibly fertile, supporting agriculture in regions like Java and the Andes. Geothermal energy is another benefit, providing a renewable energy source in volcanic regions like Iceland. On the downside, densely populated areas near active volcanoes face the constant threat of disaster. While eruptions cannot be prevented, their impacts can be mitigated through preparation. Scientists use seismographs, gas sensors, and satellite monitoring to detect warning signs like tremors, gas emissions, and ground deformation. For individuals, preparation includes having an emergency kit, staying informed through alerts, and knowing evacuation routes. Public education campaigns in high-risk areas, such as Japan and the Philippines, ensure communities are better equipped to handle emergencies. Volcanoes remind us of the dynamic forces shaping our planet and the universe. From creating new lands to influencing global weather, they are a testament to Earth's ever-changing nature. By studying and respecting these natural wonders, we can coexist with their immense power.